So we're going to pick up where we left off yesterday. Yesterday we talked about synthesis reactions, decomposition, combustion, and single replacement. And this lesson finishes off with double replacement, and then we go into a new topic. So a double replacement reaction is a reaction that has two compounds as reactants, and they exchange ions between the two of them. So here, just using variables, I have AX and BY. Remember, please, that your positive ion is always written first. So you have positive, and I'm not saying that it's a positive 1 and a negative 1. It could be a combination of positive 1, negative 2, depending on what the compound is. But your positive ion is always written first. So when they hook back up, you have to have a positive with a negative. So over here, you have A, which was positive, and you have Y, which was negative, B, which was positive, and X, which is negative. A and B represent your cations, or your positive ions, and X and Y represent your anions, or your negative ions. So you can see that X replaced Y, and Y replaces X. I really think that's supposed to be X replaces Y, and B replaces A. But you understand the drift. They're switching partners. So in the example here, we have NaCl, which is +1, and Cl, which is -1, K, which is +1, Br, which is -1. Where am I getting these? I'm getting them off the periodic table. It's the oxidation numbers. So here, because everything's +1, -1, they just hook up with their new partner. We don't have to do any dropping and crossing. We don't have to do any balancing of equation, which, if it wasn't 1-to-1, we would have to do. These are the formal steps for writing double replacement reactions. If you understand what's happening, I don't think you have to write out the formal steps. If you feel more comfortable writing out the formal steps, then by all means do so. So I write the reactants. I identify the ions in the compounds, meaning what's making them up. I need to know their charges, okay? That's really important, which isn't even written here. But I need to know their charges so that when they pair up with their new partner, I know if I have to drop and cross. I'm going to write the formulas for the products, and then I need to complete the equation and balance it. So I'm going to model all of that for you. So what I like to do is, before I even start, I like to put my charges. So this says calcium hydroxide, and you know that that 2 after the OH, that came actually from the Ca. Ca is +2. Hydroxide is a polyatomic ion coming from table E, and it has a charge of -1. My hydrogen is +1, and my Cl is -1. So when calcium and hydroxide got together, because of the +2 -1 charge, they dropped and crossed, so it became CaOH2. When things recombine, I am not carrying that subscript with me. So my Ca is going to hook up with my Cl, right? Positive with negative, and HOH is the same as H2O. Now, we know that the calcium is +2 because I wrote it down on the left. This is -1. So here I have to drop and cross, and this 2 comes down here, because then my net charge is 0 on the compound. And we know that all compounds have to be 0. So I'm not really interested when I'm looking at a reaction. I'm not really interested in any of this that's written on the top here, okay? That's just there because I'm trying to figure out what's going to hook up with what and how are they going to recombine. That really wasn't a good color. So I'm not interested in these oxidation numbers, only when I'm trying to figure out what's combining. All right, so now I have to balance my equation, right? I'm going to balance my equation. On the right, I have 2 chlorines. On the left, I have 1. So I'm going to put a coefficient of 2 right there. That gives me 2 chlorines on the left, 2 on the right. It gives me a total of 2 H's here and another 2 H's here. So that's a total of 4 H's. So I need to put a 2 here because 2 times 2 would then give me 4 H's. I also have 2 O's on the left from the hydroxide, but I have 2 O's on the right because of that 2 in front of the water. So now I'm balanced. Okay, let's try another 2 more for practice. Let's see, my Na is going to be +1. My OH is -1. My Cu is a transition element, and it either has a +1 or +2 charge, but because this 2 is here, I know that I used the +2 charge on the copper, and my Cl is -1. All right, so remember positive goes with negative, so Na is going to hook up with Cl, and notice I just write things down. I don't drop and cross yet. And my Cu is going to hook up with my OH. So going back to my charges, my Na was +1, my Cl is -1. Those are good. I don't have to do anything. My Cu has a +2 charge, and my OH has a -1 charge. So there's a problem. So I got to put this in parentheses and bring that 2 down. Now I have to balance the equation. So on the left, I have 2 chlorines. On the right, I only have 1. So I'm going to have to put a 2 here. But that gives me 2 NAs. Let me change the color on that so that you can see it better. So I'm going to put a 2 here. And then I need to put a 2 here. So I have 2 NAs on the left. But that also gave me 2 OHs on the left, which I already have. So now my equation is balanced. In looking at the last one with KCN, we see that K has a +1 charge, and CN is a polyatomic found in table E with a -1 charge. My H is +1, and my Br is -1. This is an easy one because everything is just +1, -1. So they just switch partners. K hooks up with Br, and H hooks up with Cn. Everything is nicely balanced. So on this last slide, we're going to put it all together. We are going to talk about why things are the way they are, and we're going to classify the equation either as synthesis, decomposition, single replacement, or double replacement. So in the first one, we have ammonia plus sulfuric acid, H2SO4, and that combined to make ammonium sulfate. So we have to balance the equation. I'm going to do the tally method just to review that. NHSO. So I have 1 N, 5 H's, 1 S, 4 O's. And on the right, I have 2 N's because there's a 2 after the parenthesis. I have a total of 8 H's, 1 S, and 4 O's. So I have to figure this out. So probably the easiest thing is to address the nitrogens first. So if I put a 2 here, this changes this to 2. It then gives me 2 times 3 is 6 on the right, on the left, plus the 2 H's in H2SO4. So that changes that to an 8. And then I'm balanced, so that's all I had to do. Notice that I have the format of A plus B yields AB. So this is a synthesis reaction. All right, on the next one, I have NABR and COOH2. So those are two compounds, and I noticed that the Na hooked up with the OH and the Cu hooked up with the Br. So let's talk about that. So Na is +1, Br is -1. Cu, because of this 2 here, was +2. And the OH is -1. So everything's +1, -1 with the exception of Cu. So when Cu came over here and hooked up with the Br, it was a +2 and a -1. So we had to bring down that 2. All right, let's balance. I'm going to just change color here. Okay, so I have 2 Br on the right, so I'm going to put a 2 here. That gives me 2 Na, so I'm going to put a 2 here. That now gives me 2 OHs, but I have 2 OHs, so I'm balanced. So this has the format of AB plus CD yields AD plus CB. So this is double replacement. I'm just going to abbreviate that DR. All right, in the next one, we have lead, which is a single element, and we have a compound. And we can see that lead hooked up with the PO4, or with the phosphate, and it pushed the hydrogen out. So this is very typical of single replacement. So if I look at table J, all right, on table J, I will see that lead is above hydrogen. So that means it's more reactive, it's able to push it out. So when we look at this, we see that the lead hooked up with the PO, right? The phosphate ion was split up, and it became lead. I think there's a 4 missing here. This is a typo. It's supposed to be PB3, PO4, 2. And the reason that I know that is because of this 3 here, because the PO4 has a -3 charge. And that means that PB was using +2, the PO4 is a -3, so when you dropped and cross, it became PB3, PO4, 2. So there's a typo there. All right, let's see if it's balanced. I have 2 PO4s on the right, so I need 2 on the left. That now gave me 6 H's, so I have to put a 3 here. And I have 3 PBs, so I have to put a 3 here. And we said that this was single replacement. So this has the format of A plus CD yields AD plus C. All right, and on the last one here, I have CaCO3, which breaks down into CaO and CO2. So this is actually balanced. I have 1 Ca on both sides, 1 C on both sides, and 3 O's. So I don't have to do anything. All of these coefficients are essentially 1s, which we don't write. And this is going to be decomposition, because it has the format of AB yields A plus B. All right, and that is it. Once you're done with this, play the next video.